Another important point is that the blade should remain vertical all the time. The proper stroke is going to be like this, a steady, smooth, up and down stroke. You want to avoid working at an angle, like this, and also avoid the tendency to rock, like that. And finally, and I would say most importantly, the hand holding the saw frame should be extremely relaxed. In fact, to say that it's holding is an overstatement. Cradling is probably a better term. The frame is just barely supported in my grip. You put all that together, and it looks like this. Once you've learned how to control the saw blade, it's important that you make a line that you can see well and that's relatively permanent. There are a couple ways to do it. One possibility is this material, a commercial die, comes in this jar with an applicator brush and dries very quickly. Another version that achieves the same result is white shoe polish. Or the method that I like uses label making stock. This is a sticky backed paper. One brand name is Crack and Peel, for instance. You can buy this at office supply stores or quick copy houses. I like this because it's a real paper surface, holds pencil well, and can be erased. That's what I've used for the example. There are a number of times when you might want to saw out two identical pieces. A good way to do that is to use tabs to lock the two pieces together. After making those 4 cuts in both pieces of metal, I'll now separate them and complete the V in one unit. And either one could be used. I'll use the top unit. Now, having cut out these triangular pieces, I'll put the sections back together, and with pliers, fold up the tabs in the lower unit. These are then pressed down. And that will hold the two pieces from slipping in any direction while I do the piercing. After the interior cuts are made, then I'll cut away the outside and clean up the final project. The next step is to drill a hole in each one of these sections. In order to locate the hole, I'll start by center punching. The effect here is to make a little dimple in the surface of the metal. It doesn't have to be deep. This tiny crater will prevent the drill bit from wandering. The hole can be drilled with a hand drill or, more typically, with a flexible shaft machine. The flexible shaft machine, or flex shaft, is a popular and versatile tool. Its small precision motor is generally operated through a foot rheostat, like those used with sewing machines. The harder you push the pedal, the faster the motor turns, usually going at about 14,000 RPM at top speed. The flex shaft is used for drilling, grinding, carving, and polishing. Goggles should always be worn when using this machine. When sawing an interior area, in a process called piercing, I first loosen the blade and thread the object onto it. Then the blade is tightened as before. To remove, the blade is released from the gripping plate below, and the process is repeated. Interior spaces are cut first, and then the metal around the pieces are sawn away, except where the tabs are holding. As a final step, I'll cut off the tabs. Even if this was going to be a pin, I'd have to find some way to attach a finding to the back. There are two approaches to this, one way that uses heat and one that doesn't. Every once in a while it's possible to make a piece of jewelry out of a single piece of metal, but far more typical is the case where you join 2 or 3 or sometimes dozens of pieces together. There is a family of connections called cold connections, which is not what happens when you put your tongue on the flagpole in winter, but rather cases where pieces of metal are mechanically wrapped over one another in ways that do not involve the heat of soldering. I'm going to show some standard devices in this family of cold connections, but before we get to that, I want to make the point that cold connections are all around us. By looking around, you'll find many examples that can be adapted to your work as a jeweler. For instance, here. Typical example, and the most familiar one to all of us, is the paperclip. Another familiar example is the staple. Here's a case where this potato peeler is held together without a soldered joint. Right here, the metal curls over and wraps onto itself. It makes a surprisingly strong joint. This can opener is held together with a rivet at this end and a tube rivet at this end. Examples of cold connections can turn up where you least expect them. For instance, the mechanism inside this toy is held together with tabs which, like fingers, reach through holes and press down on the top plate to hold it all together. As basic as they are, tabs present an opportunity for design enrichment as well. In this case, for instance, I want to hold a piece of copper onto a piece of brass, and I'm going to use tabs which will become a part of the design. For this piece, I've cut out triangular tabs and bent them up at a 90-degree angle. On this copper unit, I have corresponding slots so that the two, if I've measured correctly, will slide together like that. I'll then set the piece onto the bench anvil and press the tab over, the intention being just to take it away from vertical, and then with a rawhide mallet, tap it on down. Like that.